Hey everyone, welcome back to the channel. Today we are going to discuss about the most important Viva questions related to hardness of water. I will be trying to cover all the important questions that can be asked from this topic. So let's get started. Firstly, what is hardness of water? Hardness in water is characteristic that prevents the formation of lather with soap. This is due to the presence of calcium or magnesium and other heavy metal salts dissolved in it. What is the difference between soft water and hard water? Water which forms lather easily on shaking with soap is called as soft water. On the other hand, water which does not produce lather with soap easily but forms a white scum is called as hard water. What are the disadvantages of hard water? The limitations of hard water can be seen in various domestic applications, such as while washing. The sticky precipitate adheres on the fabric or cloth and gives spots and streaks. Iron salts stain the cloths. In bathing, hard water produces sticky scum on the bathtub and the body. Hard water is also bad to the digestive system, and calcium oxalate formation is possible in urinary tracts. In cooking, it requires more fuel and time. Certain food don't cook soft and also gives unpleasant taste. What are the different types of hardness? How are these caused and how to remove them? There are two different types of hardness. Those are temporary hardness and permanent hardness. Temporary hardness is caused by dissolved bicarbonate of calcium, magnesium, and other heavy metals and carbonate of iron. Permanent hardness is caused due to presence of chlorides, sulfates of calcium, magnesium, iron, and other heavy metals. Temporary hardness can be removed by boiling of water when bicarbonates are decomposed, yielding insoluble carbonates. Permanent hardness can't be removed by boiling and requires special treatment like zeolite process, lime soda process, and ion exchange method for its removal. What are the reactions involved in removal of temporary and permanent hardness? In temporary hardness, calcium bicarbonates on heating break down into calcium carbonate, water, and carbon dioxide. This calcium carbonate formed is insoluble and thus get deposited as a scale at the bottom of vessel, while carbon dioxide escapes out. In permanent hardness, sodium stearate or sodium soap reacts with calcium chloride to form calcium stearate, which is again insoluble. If the reaction is carried out with magnesium sulfate, then magnesium stearate formation takes place. Which type of hardness are we finding in this experiment? We are finding total hardness followed by permanent hardness. For temporary hardness, we will be taking the difference of above two. Which type of titration is being done in this experiment? We are performing complexometric titration. What is complexometric titration? It is that type of titration where the endpoint is determined by formation of complex. What are the different units of hardness? The different units of hardness includes parts per million, milligrams per liter, degree Clark, and degree French. What is the relation between these different units? 1 ppm equals 1 milligram per liter, which is further equals to 0.01 degree French and 0.07 degree Clark. What is the full form of EDTA? Draw its structure. EDTA stands for ethylene diamine tetraacetic acid. Did we use EDTA itself? Give reason. No, we did not use EDTA. Instead, we have used disodium salt of EDTA in the experiment. This is because EDTA is sparingly soluble in water. What do you mean by versinate? Versinate is the commercial name of EDTA. It forms stable and unionizable complex with hardness-causing ions like calcium and magnesium. Which indicator is used in the experiment? We have used area chrome black T or EBT as an indicator in the experiment. Give the reaction of EDTA with EBT when the EBT indicator is added in small amount to hard water. It forms wine-red color complex with calcium or magnesium ions at pH 10. When this solution is titrated with versenate, all the hardness-causing ions react with versenate, and at endpoint, the wine-red colored complex of metal EBT breaks. The metal ions react with versenate, and free indicator, which is blue in color, is released in the solution. What pH of buffer is used and why? We have used 10 pH buffer, and this is because the complex formation takes place at specific pH level. Why ammonia is added to the solution? Ammonia is added to the solution for its quick dissolution. What is the need of boiling during the experiment? Boiling is done to remove the carbon dioxide, which is produced during the process. How is the endpoint determined in the experiment? The endpoint is determined by the formation of stable colorless complex between EDTA and metal ion, such as calcium or magnesium, releasing blue-colored indicator EBT into water. What are the different formula used in the experiment? There are 3 different formulas used in this experiment. For total hardness, we used 1000 V2 divided by V1, where V2 represents the volume of water sample after titration, and V1 represents volume of burette. For permanent hardness, we used 1000 V3 divided by V1, where V3 is the volume of boiled water sample after titration, and V1 is volume of burette. Finally, for temporary hardness, we have subtracted permanent hardness from total hardness. Why did we express hardness in calcium carbonate equivalents? We did so because calcium carbonate is most insoluble and easily precipitable salt. Also, its molecular weight is 100 and equivalent weight is 50. As these are whole numbers, it is very easy to use them in calculation. With this, we come to an end. Thanks for watching, and do give your valuable feedback in comment section.